Hi everybody. So let us try to discuss about the basics of operation amplifier. So as name itself indicates that it performs operations. So it performs operations as a comparator, adder, or you can say summation amplifier, then difference amplifier, then inverting amplifier, non-inverting. Then it can perform operations, mathematical operations such as log, anti-log, then differentiation, integration, multiplication, division. Then it can act as a filter. Then we can use this for design of the oscillators. So if you see the papers of competitive exam, then at that time there will be few questions on the operation amplifier where you need to understand the characteristics of the operation amplifier, like common mode rejection ratios, slew rate, then input offset current, input bias current, input impedance, output impedance, then open loop gain, closed loop gain. What is repercussion of the negative feedback? What is the use of the positive feedback whenever we design RC oscillators or LC oscillators? And how we can go for the high frequency analysis by using this operation amplifier, as well as how we can design the different circuits by using this operation amplifier, that we need to discuss in much more detail. So this topic will play very much important role in any competitive exam. So during this session, what we'll do is that we'll try to understand about few points, few operations like inverting amplifier, non-inverting amplifier, and difference amplifier. What it So now let us focus on the non-inverting amplifier. Amplifier as symbol electrolysis. So I know that operation amplifier is having inverting terminal, non-inverting terminal. I will treat this as a V1, this is V2. Output is V0. Here VDD is applied or VCC is applied plus VCC. I have minus VEE. A is open loop gain of this amplifier, and in feedback I have feedback resistor RF. Then this resistor value is R1. Then we have this, I will use same resistor as RF. This is R1 plus minus Vin. Okay. Now let us try to understand what should be the value of V1. Why? Because this operation amplifier is having high input impedance. Rin will be in few mega ohm. So current will not pass here. This is V2. This is V1, non-inverting terminal, inverting terminal value. Now what will happen is that as current will pass in closed path and least opposition path, current will not pass here, all current will pass here. So let us apply voltage division rule. So what is voltage division rule? What is V1? Use voltage division. So V1 is equal to Vin into Rf divided by, I will be using a voltage across Rf with reference to ground divided by R1 plus Rf. I got this V1. Now I know that V0 is equal to, what is now value of V0? V0 is equal to non-inverting amplifier. V0 is equal to 1 plus Rf upon R1 into V1. So R1 plus Rf upon R1 into, what is value of V1 from this equation? Vin into Rf upon R1 plus Rf. So this will cancel with this. So Vin into Rf divided by R1 is nothing but V0. So I will get V0 upon Vin, closed loop gain. I am using a negative feedback, which is equal to Rf divided by R1. Got this point? Now you'll say that how I have written this V0 is equal to 1 plus Rf upon R1 into V1. Now for that purpose, what we'll do is that we'll try to minimize this and let us consider V1. I should get the answer as a 1 plus Rf upon R1 into V1. So let us try to do that. So let us consider I have applied voltage V1 here to the non-inverting input. Now what is relation between V0 and V1? Again, negative feedback is used. Now what will happen is that current passes from higher potential to lower potentials. I will consider IF. This current I will consider as a I0 or I1. This is or I2. This is I1. Now I2 will become 0. L equal to 0. This is my assumption. Why this is my assumption? Because I have high input impedance. So if I will apply KCL at this point, KCL, IF is equal to I2 plus I1. But now I2 is equal to 0. IF is equal to 0 plus I1. IF is equal to I1. What is IF now? V0 minus V2 divided by RF is equal to V2 minus 0 divided by R1. But what is now V2? V1, V2 is equal to V1. Why? Because whatever this potential is there, that same potential will appear here. V2 is equal to V1. So V0 upon RF is equal to V1 upon R1 plus V1 upon RF. Isn't it? So I will get V0 upon RF is equal to V1 into R1 plus RF divided by R1 RF. So RF will cancel. So let me write here V0 upon V1 is equal to R1 plus RF divided by R1. 1 plus RF divided by R1. So if you try to recall the previous example where we have R1 here, RF here, and Pin was applied, at that time we got V0 is equal to, sorry, V1 is equal to Pin into 1 plus Pin into RF divided by R1 plus RF. At that time we got the expression V0 upon Vin, correct? So similarly here we got the expression V0 upon V1 which is equal to 1 plus RF upon R1. So this is nothing but now your closed loop gain with negative feedback. What is point? So if an important point is that you need to find out whether there is some network here or no. If network is not there and V input is directly applied here, V1 is equal to V in, V1 is equal to V in, then this expression directly I can write V0 is equal to V in into 1 plus RF upon R1 which is equal to V in into AF gain with feedback, because this operation amplifier will be having open loop gain as A, and with negative feedback I will get decrease in a gain. AF is equal to A divided by 1 plus A beta. So beta I can find out, and by using that we can do the analysis. Now let us do that also. Okay, now let us try to understand with negative feedback how we can do this. With negative feedback, gain with negative feedback is equal to A divided by 1 plus A beta. Now A into beta is always greater than 1. Correct? So AF is equal to, approximation is equal to 1 plus A beta is equal to, is nearly equal to A beta. So AF is equal to A divided by A beta, 1 by beta. Now what is beta? Now what will happen is that as current will originate from higher potential to ground, what will happen is that voltage division will happen. So R1, voltage is taken across R1, and this is nothing but RF. This is nothing but V0. Correct? So what is my beta factor? Beta factor is nothing but how much voltage is present across this with reference to the output V0. So this potential is nothing but, this is feedback voltage. So Vf is equal to V0 into R1 divided by R1 plus Rf. So we got Vf upon V0 is equal to beta, which is equal to R1 divided by R1 plus Rf. So what is AF? So if we try to find out AF, which is equal to 1 by beta R1 plus Rf divided by R1, 1 plus Rf divided by R1, which is AF. So V0 is equal to V1 into 1 plus Rf divided by R1, isn't it? So same thing I have written. V0 is equal to Vin into 1 plus Rf upon R1. Here Vin is nothing but V1. Vin is nothing but V1. So this is basically we need to understand what is impact of the negative feedback. With negative feedback, what will happen? Distortion will reduce by factor 1 plus A beta. Noise will be reduced by 1 factor 1 plus A beta. Bandwidth will be increased by factor 1 plus A beta. Input impedance will be improved by factor 1 plus A beta. Then output impedance will be reduced by factor 1 plus A beta. Then we can say that gain will be reduced by factor 1 plus A beta, isn't it? So by using these characteristics also we are getting the same answer. So now let us discuss about inverting amplifier. So now inverting amplifier. Now what is inverting amplifier? It will perform the operation which is nothing but complement of the input, invert of the input. 180 degree, output will be 180 degree out of phase with reference to input. So I have operation amplifier, negative, positive. This point I will use offset minimize resistor. This is V0, this is RF, this is R1, and here I will apply input. Here this is VCC minus VEE. Open loop gain is A. Okay, so for this amplifier. Now what will happen is that this is V1. V1 is equal to 0, V2. V1 is equal to 0. Therefore, V2 is also equal to 0. Why? Because V0 is equal to A into VID. A is very large. Few lakhs open loop gain. So VID is equal to V0 by A, which is near equal to 0. So VID is equal to, what is VID? VID is equal to V1 minus V2 is equal to 0. So V1 is equal to V2. So what will happen is that V2 is a virtual ground. This point is not actually connected to ground, but will get a virtual ground. That means this will, what is the difference between ground and virtual ground? Ground will be having zero potential. It can sink infinite current. Virtual ground will be having zero potential and current passing through this virtual ground will be equal to 0. Because I have input impedance which will be in few mega ohms. Now what will happen is that current will not pass here, so I2 is equal to 0. So this is I1, this is IF. So KCL at V2, I1 is equal to I2 plus IF, but I2 is equal to 0. What is I1? V in minus V2. V in minus V2. Potential difference between these 2 points divided by resistance value R1. V2 minus V0 divided by RF. V2 is equal to 0. So V in upon R1 is equal to minus V0 upon RF. So V0 is equal to minus RF upon R1 into V in. Now here negative sign indicates that your output is 180 degree out of phase with reference to input. So K is nothing but your scaling factor, or RF upon R1 is nothing but closed loop gain. So here you have gain as a negative. So AF is equal to minus RF upon R1. Get this point? So this is about inverting amplifier where output is 180 degree out of phase with reference to input. Now most of the time we need to find out potential difference between two applied voltages. So let us think about difference amplifier. So I have a difference amplifier, negative, positive. I will use here values RF, R1, this is V1, or this is Vx, this is RF, V0, R1, this is Vy. So I should get Vx minus Vy as a output difference. What we can do? Now I have more than one source here, so we can use a superposition. So use superposition. So consider only one source at a time. Replace other source by its internal impedance. Internal impedance of ideal voltage source will be short circuit. So what will happen is that this, consider Vx, Vy is equal to 0. So what will happen? I will get a structure like this: R1, Rf, Vx Rf R1 V01 or V0, okay, V01. So V01 is equal to, what is inverting amplifier? Inverting amplifier potential V1 will be multiplied by gain 1 plus Rf upon R1, which is V1 into Rf plus R1 divided by R1. Now to get a value of V1, what we need to do is that we need to apply the voltage division rule, because current will pass here, current will not pass here as it is having high input impedance. So V1 is equal to V01, V1 is equal to Vx into Rf divided by R1 plus Rf into Rf plus R1 divided by R1. So Rf upon R1 into Vx, equation number 1, isn't it? Now B point is that consider Vy and Vx is equal to 0. So R1 parallel with Rf will behave as a offset minimizing resistor. V02 Rf R1 Vy. So V02 is equal to, what is now V02? Inverting amplifier. Already we have discussed about inverting amplifier. So minus Rf upon R1 into Vy. Equation number 2. So this is by using superposition. We have considered each source independently, all sources is replaced by short circuit. Now let us try to find a V0. What is V0 now? Algebraic sum of V01 and V02, because we got two expressions, Rf upon R1 into Vx minus Rf upon R1 into Vy, which is Rf by R1 into Vx minus Vy. If we wish to get this potential is equal to 3 volt, 5 volts, this potential is 3 volts. So 5 minus 3, 2 volt potential difference. If I wish to get, then Rf should be equal to R1. So V0 is equal to Vx minus Vy. So this will become a difference amplifier, right? So what you need to do is that to get a good score in a competitive examinations, 1 mark or 2 marks question will come, and they will add some circuit at this input, correct? So you need to think about how operation amplifier is used, and as name itself indicates, it is operation amplifier. It performs operations. So you need to understand about difference amplifier, then summing amplifier, then log amplifier, anti-log amplifier, then integrator, then how to perform the derivative, how output is proportional to derivative of the input, then how it is used for filtering operations, how it is used for generation of the square wave, how it is used to generate a triangular wave, or how it is used as a first order filter, second order filter, Butterworth filter, or Chebyshev filter. What is the response? How it is used? What are the limitations at the high frequency? Isn't it? Then what are other operation circuits which we can design as a multiplier, then divider, isn't it? So in next subsequent session we'll try to discuss about other operations. So I will stop here. Thank you very much.